Let's review the tools and equipment used for testing components. We'll need VOM, breadboard, long nose pliers, tweezers, alligator clips, and if you have helping hand. Proper handling of isolated components and VOM. Number 1, always use a breadboard or alligator clips or tweezers or long nose pliers to hold the components. You do not get the accurate value of charge when you touch its terminals or when the components are lying on the table. If you are using a breadboard, make sure that you are going to place the resistor in between the gap of this breadboard. So just place the resistor just like this and you're ready to go. And if you're going to use an alligator clip, just connect the alligator clips to the test leads and then connect the terminals so this way you won't hold the terminals of the components. You'll get the accurate value. To use the tweezers, ask someone to hold the tweezers for you and then you will be able to test the component just like this. And for long nose pliers, you can also ask someone to hold this for you so that your two hands will hold the negative and positive probe and then test the components. And then for the helping hand, if you have a helping hand, you just have to adjust the hands and then test the components. We will test a resistor. So first, we need to know the resistance of the resistor. So since this one is brown, black, yellow, and gold, its resistance is 100,000 plus or minus 5% ohms. The maximum tolerance is 105,000 ohms and the minimum tolerance is 95,000 ohms. We will set the VOM to 1 times 1K and then we will calibrate. We will calibrate first the VOM by connecting the negative and positive probe and then you are going to adjust the 0 ohm adjustment knob and until the pointer reaches 0. We are ready to check or to test the resistor. Just touch the terminals and then look at the value. It shows that this resistor is 100,000 ohms. Since 100 times 1K. Now we will be testing another resistor. Its resistance is 220 plus or minus 5% ohms. So the selector switch, we will be using times 10. And then we will recalibrate it, connect the negative and positive probe and then adjust the 0 ohm adjustment knob and turn it until the pointer reaches 0. And then you're ready to go if it already reaches 0. And then touch the probe to its terminals. And now we read it is 22 times 10, so that is 220 ohms. So these resistors are good. We've checked that these resistors are still good because it is still inside their maximum and minimum tolerance. When testing capacitors, we need to discharge first the stored electricity before examining it. So we'll need long nose pliers to do that. Make sure that the handles are insulated with plastic, or you can use alligator clips. You are just going to connect the two terminals, the anode and the cathode, or the negative and the positive. Or if it is a non-polarized capacitor, you just have to connect the two terminals. So I will be using precision tweezers to hold the body of the capacitor. And I'm going to use first the long nose pliers. So clip the two terminals just like this, and this way you are already discharging any electricity inside its body. Sometimes you'll see sparks. And then the next one, just connect the two terminals, and by using an alligator clip, you just have to connect the two terminals just like this. That's it. That's how you discharge capacitors.
Now it's time to test capacitors. I removed these capacitors on the circuit board. As you can see, the terminals are too short. We cannot use a breadboard this time. Instead, we will be using alligator clips. So the alligator clips are attached to the VOM. And this way, we can check the capacitors without touching the terminals. When checking capacitors, test probes can be reversed. If on first try the pointer did not deflect, just reverse the probes and observe the movement of the pointer. This is the VOM scale. Let me show you how to read the movement of the pointer. This time we will not read the numbers, we will just observe how the pointer moves. First remark is good. If the pointer deflects and moves back to the infinity, then the capacitor is good. It means that it's still working. Second remark is shorted. If the pointer deflects and it stays on a certain value or resistance, then it is shorted, meaning the capacitor needs to be replaced. Third remark is open. If the pointer stays on the infinity and did not deflect at all, it is open, meaning the capacitor needs to be replaced. We will test a 22 microfarad capacitor. You may turn your range selector switch to times 10 or times 100. It depends on where you can see the movement of the pointer clearly. Let's observe the pointer. The pointer deflects and it moves back to infinity. This means that this capacitor is good. Let's check another capacitor. This time we will be checking a 1000 microfarad capacitor. My range selector switch is still pointing at times 100. We will connect the alligator clips to the terminals. If at first the pointer did not deflect, just reverse the alligator clips. Make sure that the alligator clips do not touch each other. Let's observe the pointer. Now you see that the pointer deflects and it moves back to infinity. This means that this capacitor is good.